Hello everybody. Today I want to talk about creating 3D printed designs. Specifically a 3D printed design with electronic components that will help me solve a novel issue and have a novel solution. What I'm going to be doing is walking you guys through from the start, where I have the problem, what my potential solution is, to picking the electronic components, and in the end 3D printing the design, creating the 3D printed design, and at last building it all together and talking about how it works. So if you're interested in 3D printing or just want to see a fun design being made, stick around and find out and see how it goes. First, let's go take a look at the problem I'm trying to solve and what I think 3D printing and designing a machine could solve for me. Okay, so I grow some chilies and tomatoes hydroponically, and over the years I have developed my own recipe for fertilizer stock solution. Usually I'm mixing around 2 liters at once. The issue is, recently my friend asked me if I could mix some fertilizer stock solution for him. And mixing only 2 liters at once is very inefficient. So let me show you the setup and then tell you why it's inefficient and how I want to go about mixing more than 2 liters at once, in fact up to 10 liters at once, and reducing the amount of parts I need, making the process much easier. I want to replace all of these parts with a 3D printed machine and this bin. When mixing fertilizer stock solutions, I always use the scale to make sure I get an accurate amount of water. So if I need 500 milliliters of water exactly, or 550 milliliters of water exactly, I weigh it out in this thing. Now you could ask, why don't you just use these lines? Because they are not accurate enough. Here it claims a plus minus 5 milliliter difference, but really I found this is 25, 30 milliliters difference because these drawings are just not accurate. As well as this is only 500 milliliters. So if I wanted to make 10 liters, I would need to weigh this off 20 times. Let me show you the procedure. I tare it, and now the scale is at 0. Now, I will proceed to use my reverse osmosis system so I can get clean water for the stock solution. So usually when I'm making stock solutions, I'm weighing off my water for the stock solution to get a precise amount, right? Now, as you can see, that's 499 grams, and there it's not exactly precise. But again, the second issue is as well, I need to do this 20 times now to get 10 liters worth of stock solution. This is a big hassle. Also, the precision drops in every round that I go do this over and over again. The next step to my process would be taking a large container, adding the water to it. Now I'm limited due to the size of this magnetic stirrer of what I could put on top of here. Adding this bucket, for example, is a little bit large in my opinion, and I risk it falling off. Now usually I would repeat this step multiple times using my calculator to type in the amount here. 400, let's say I filled it up to 499 plus 135 is 634 milliliters. So now I would know there's 634 milliliters within this container for sure. Now I want to make this process easier, along with making stirring in bigger amounts more reliable. Now once I have this amount measured out, I would add the correct amount of fertilizers to this and mix it with the stirring plate. The machine I will be building today should be taking over the tasks of the scale. It should not be limited to only 500 grams as this scale is, and should take over the task of the magnetic stirring. Alongside this, it should turn on and off my reverse osmosis machine automatically once the correct amount of water is within the bucket. So my dream is I will have a remote that I type in 500 milliliters into, then my machine will turn on and fill my bucket up to 500 milliliters, and once that's done I can stir it on the exact same position. So while I'm filling 857 or 2,560 milliliters. This will no longer be a hassle because I no longer have to repeat the process of weighing out small increments one step at a time, especially for larger volumes, because with this new machine I would be able to kick back, relax in another room, and everything will be handled and taken care of automatically. The only thing I need to do is weigh off the fertilizers and throw them in the mixture. For all of this, I want to use this bucket. It's a 10-liter PP bucket. I want the bucket to stand up. It should have a scale and a magnetic stir under it at the same time. The scale needs to handle up to 10 liters of water, so 10 kilograms. And alongside this, I need a valve that will turn on and off the flow automatically from my RO water. Let's get to creating this machine. My plan is pretty simple. I would have a rectangle that holds the bucket. It doesn't need to be the full width of the bucket. It doesn't need to be the full length of the bucket. It just needs to be the width. So this area would have to be as deep as the bucket. So this is the bucket. It wouldn't need to be the full length, just the width. So the bucket is approximately 21 centimeters. Then I would have some things that come out to hold it. So I have a simple rectangle with pieces that come out to hold the bucket at the top and the bottom. So I would add an extra 5 centimeters to the top and the bottom, or maybe only 2 centimeters. And then everything should fit on the print plate. So the P1S print plate is 255 millimeters, and this in total would be 250 millimeters. So this should fit. How wide this is doesn't really matter. I want it wide enough for the bucket to be stable, but not too wide to waste filament. So maybe 170 millimeters or 17 centimeters, however you want it. Now this area would hold the bucket, and usually how a scale works is you have the beam which measures the force being pushed down here. The beam is attached down here, and up here the force is measured. So you put your item you want to weigh here, and this metal beam will bend a certain amount, and the voltage that will change can be measured by a microcontroller. So in this design, what I want to do is add 4 5-kilogram beams to make the readings more reliable and more precise. I would put the beams facing inwards to save space. So I will add little notches. Here's one of these beams to demonstrate. They have these 2 dots, and I'm going to add notches to hold them. So these are the notches to hold the beams. So if you would look at this from another perspective, you would just have this piece, and the beams should be going inwards. All I need to do to measure the weight of this is keep the beam independent so it can move up and down. So I would put some legs down here to hold this top platform, and then I can have a microcontroller that measures the difference in voltage in order to get the weight. This way I can get the weight of the bucket. You might be asking, why am I getting the weight of the bucket and not trying to measure it in milliliters specifically? That's because 1 gram of water is equal to 1 milliliter, as long as you have clean and pure water, which with RO water you do. So measuring the weight will give me the exact amount in milliliters. Now, I don't only want to measure the weight of the bucket. I want the water to start and stop flowing automatically, so that when my target weight, let's say 550 grams, is reached, the valve closes and stops the water flow, that only 550 grams, 550 milliliters of water end up inside the bucket. As well as this, I would like to have a way to mix the water, which we already established would be a magnetic stir rod, and this stir rod would probably go here in the middle. 4 magnets to have stronger strength and spin on a plate, and then there has to be a motor down here somewhere powering everything, maybe with some gears, maybe not. Let's see. Let's get to the CAD program and start designing the 3D printed parts. Alright, so here's what I've designed so far. This would be a virtual representation of the bucket. And below the bucket would be the stand, which attaches to the force gauges. As you can see, the 4 force gauges will attach these pieces together. This is the top, which would hold the bucket. So it's very simple. The top, the force gauges, and the legs, so that the weight will be on the force gauges to measure the difference of before and after. Now, I haven't fully decided where to put the motor yet. I was thinking maybe I'm going to have gears to keep it a little bit flatter and lower, and inside here I would keep the valve and have a tube that goes up and has a little like water handle coming down. Now, this is clearly not a final design yet, but this is a very basic design that has the parameters of the strain gauges hopefully correctly. I will be printing it to test out if this is correct. So let's print this prototype, build it together, see where we can go, and then we'll expand on this prototype and build a final version after. This is the design you just saw a second ago. Short stubby legs and the top piece. You can see the top piece is only mounted to the bottom piece through these 4 bars. And all of this is evenly spaced so that the weight is evenly distributed among these 4 pieces. So before I show you this device, I want to quickly talk about my little remote. To avoid any extra wiring in these devices, I built an NFC remote for my devices. With this remote, I can scan NFC tags, I can clone NFC tags, and more importantly for this video, I can set up an NFC tag with a MAC address connecting to my ESP32. You guys don't need to understand any of this. The point is, I can use this thing to scan my ESP32 and then control it. So this works as a display and buttons. You could build this device or a device like this easily, just add a display and some buttons and some controls. To avoid all of that, I built this thing. So I plug in my scale. This is what I've built so far. I connected these 4 guys all to my HX711 chip, which is connected to the ESP32 over here. So now I take my remote and I scan the NFC chip over here, at which point it connects me to the device. Now I can tear the scale and read the weight. So currently the weight is negative 0.26 grams, negative 0.33 grams, negative 0.29. So it bounces around a little bit between negative 0.5 grams and negative 0. I'm going to take a 10 gram weight and add it over here. And as you guys can see, 10.16 grams. So I can add another 100 gram weight, and this should give me 110 grams and 107 grams. So as you can see, it's more or less precise. Let me add some more weights and see how it goes. Now I have 4 different weights on there, and this should give me 150 grams. 148.7. So I'm happy with this precision. If this can do up to multiple kilos at plus minus 10-20 millimeters, plus minus 10-20 milliliters, I'd be quite happy with it. So maybe one thing I have to test out before going on to a more final design than this is how much weight can this thing take. So maybe I'll add a drink. Whoa. Now I can see on my little remote it's 950 grams. Let's add another drink. That's 1,800 grams. 1,870 grams with 2 drinks on the scale right now. Technically I only need up to like 10 kilos, but I don't have any super heavy objects lying around, so I will just trust that it can handle up to 10 kilos. Now the fact that my system with the wireless remote and the scale that can weigh up to 10 kilos, especially in the size of my bucket, the fact that this works makes me very happy. I can just put my bucket on there. This should work. But there's a little bit more to this machine. I still need to fit this big ass motor over here. I want to fit it here in the bottom. I've thought about this for a while and I think this makes sense. So I get directly from the wheels spinning, which will give me minimum noise, because if I'm using gears, it's going to be super loud. So I'm going to put this motor over here. I will need to put places for these wires to be hidden along the side. And I want to attach the chip here on the side. Aside from this, I need to create a housing so I can fit the water valve in the back and turn the water on and off once my desired amount of milliliter is reached. So yeah, let's get to designing that in CAD. Alright, so I've made some changes. I've added the water fountain at the top. So I would plug in my reverse osmosis system here in a hole in the side. That's where the valve is, attached down here. So the water would go in through here. And if I set the machine to a certain quantity of water, it will open the valve, which would, through a tube, go up here, all the way through this thing, and empty the water out into the bucket. Now, how did I create this, or how do I want to print this? It's screwable piece that is flat on both sides so it can print easily. This is also flat on the side to make it more easily printable, screwable, and the bottom has the screwable piece as well. I'll just push a tube through this, and it doesn't need to be waterproof because the tube will just end right here at the same spot. Now, other changes I made is I added a scan here area for my NFC tag. I made these pieces a little bit thicker. I added a spinny wheel to stir the water. As you can see, I can put 3 magnets on top of each other, stick them here. So in total, this thing takes 12 magnets to have a stronger, tighter hold. Now I also added some space back here for the USB-C plug and some electronics. I added a lip to avoid water from coming in, and added some barriers between the water valve and the electronics to also avoid water from getting to the electronics. I added holes for the wiring, and with the bottom piece, I added a lot of little wiring holes as well. You can also see that the bottom piece can now hold the motor in these 2 holes. This is easily 3D printable. As you can see, it's a solid layer that I just have to poke through. No supports at all. Everything can just print in one piece. Same for all the other pieces as well. And yeah, those are the main changes. I just added holes for wiring and electronics, added mounting points for the vents and the motors, and added a scanning area for the NFC chip. Let me show you guys how this stuff looks like when 3D printed, and then we'll build it all together. Okay, so here you guys can see the new 3D printed parts. So the first change I made is this part's a bit more flexible. This one should really not be flexible at all. It should be as stiff as possible. So I printed it in PET-CF with 3-layer walls to make it much less flexible. I really like PCF because it doesn't have any smell. It doesn't warp much. It's very moisture resistant. It's a very nice filament to print with. Another change I made is I left a little cutout location for the NFC tag. So I can take my NFC tag and just glue it in here, and then I can scan the machine instead of scanning something else. Next change I made is to the legs. You see the short stubby legs. I had no place to put the motor underneath, so I made the legs much bigger, much thicker, much chunkier. This thing weighs 300 grams, you can feel it. Now, technically this motor should fit in here. There, the motor fits. And along with this, I added this back piece, which has their inserts from screws. So I can screw this piece together like so. And this should now hold all my electronics and valves. So yeah, I think that's enough talking. Let's start screwing this thing together and let's get building.
Sin tono, dejaste roto, me caí al fondo. No me quedes sola, tengo a Dios mis solas. No te necesito más. Todo estaba tan bonito, ay, hasta que empezó a fallar. Hubiera sido infinito, así.
Okay, let's go. First test. So I have to stick the RO system into the tube. See, here's my little tube. And it's going to pour water in here until a certain weight is reached. So let me power this bad boy on. I have my remote. I wake it from sleep. I scan the chip. Bam. Now I have my menu option. I want to tare first. So that tears the scale. Now everything is at 0. Let's measure some water. I want to measure 500 milliliters. 3, 2, 1. Bam! Now let's read the weight. I wanted 500 and I'm getting 499. Yeah, I can live with half a milliliter difference. So there you go, that's the use case. If I need a certain amount of water, which I need for mixing my hydroponic nutrients, often something like 2535, then I can just use this thing, set it up, go relax in another room, and the system will handle itself the amount of water I need. It's a very tedious task. And the second main feature is the stir rod. I can now just on my remote do the mix water setting. If I click the joystick up, the stir rod will go. If I click it up more, it will go faster. So now I can easily just pour in the hydroponic fertilizer, mix the water, and measure the water all at the same spot. I'm going to take this thing back there, show you guys the circuit board really quickly, put it all back together. Also, this is my wireless remote. Again, if you want to see any more videos about it, let me know. Here's my circuit board. It has an ESP32S3, a step-down buck converter, and a motor driver. I'll blend in the specific name. It's one of my favorites. And that's basically it. All the motors just directly attach to those with wires. And it's connected to a USB-C PD set to 12 volt. Yeah, so the 12 volt goes in. It gets stepped down for the Arduino and the scale, the weights. And other than that, the 12 volt goes to the two motors. That's it. It's quite simple. Now I'm gonna put this in there. The USB-C has its own spot here, so I'll end up plugging it in there. Now I'll show you the final design. To be honest, I wanted to give it a permanent position mounted, but I think I'm going to keep it open for now. I don't really want to mount this thing right now with hot glue. There you go. It's not the cleanest or the best, but it's finished. So here it is. My final water measuring scale. It has an NFC chip. It has an NFC chip at the front that I can scan with my remote to control. It has an NFC chip at the front that I can scan with my remote to control because I don't want to build a new screen and buttons, and I don't even know where to put the screen and the buttons on this thing. So that's why I made this, but it's a different project, has a different complexity. I wanted to stick to 3-4 days, and this is what I created. It mixes the water. I chose to use this motor because I wanted a big, powerful motor. Now, in future videos, I might make some impeller designs, or I might even make a community impeller design challenge. Which impeller moves more water? But that's something for the future. How do you guys like this design? Either way, for me it solves a very big issue, which is it takes a long time to measure out the water precisely, and then it's hard to mix the large amounts of water with a small magnetic stir wand. So this does everything automatically and I don't even need to worry about it with a wireless remote. Now, if you're interested in seeing any more in-depth videos about maybe the 3D printing design process, or maybe the electronics or the wiring, anything, please let me know. Thank you very much, everybody. I appreciate you watching this video and have a nice day.